Now let's talk about bounding the tail. And questions like these are going to ask you to find a value such that the integral up until that value approximates the infinite integral to within a certain value. And in our case, we are going to call that value m, and we want to find m such that the integral from 1 to m of 1 over 5 plus x to the 6 dx approximates the infinite integral from 1 to infinity of 1 over 5 plus x to the 6 dx to within 1 over 5,000. So here's a graph of f of x, and we want to find the area under the curve. And so from 1 to infinity, that would be all this area over here up until infinity. And as you can see, we want to find the area up until this value m. So just to see what we're trying to find out, we want our error in our approximation to be less than or equal to 1 over 5,000. And our error, we can write that as our actual minus our the actual infinite integral minus our approximate. So our error would be from 1 to infinity of f of x, and we're subtracting our approximation of f of x, which is just from 1 to m, and we want that to be less than or equal to 1 over 5,000. Well, let's look at this graph. This integral is just going to be this whole thing all the way up to infinity, and this integral is going to be this whole thing up until m. Okay? So if we're subtracting just this slice out of all of that, what we're left with is this. And what it is the integral from m to infinity of f of x. And that needs to be less than or equal to 1 over 5,000. And I know this is an improper integral. So when we're solving it, we have to take that into account. So let's go ahead and write down our integral, which is going to be from as the limit as a approaches infinity from m to a of 1 over 5 plus x to the 6th, and we want that to be less than or equal to 1 over 5,000. So you could try to solve that, but I doubt you'd be able to integrate this expression. There should be a dx there. So what we're going to have to do is kind of use a comparison. And remember, anything less than 1 over 5,000, it's fine, right? So we can use the comparison that 1 over 5 plus x to the 6th is less than 1 over x to the 6th. That's always going to be true. And substitute that into here, and we'd still be fine because we'd be less than 1 over 5,000. We always want to be conservative in these problems. So we're going to substitute and pretty much solve this expression using 1 over x to the 6th. Let's go ahead and do that. Okay. So we're taking the limit as a approaches infinity of integral from m to a of, and what did we say our new integral would be? 1 over x to the 6th dx, and we want that to be less than or equal to 1 over 5,000. So now let's integrate that. And that's going to go, don't forget to write the limit. A approaches infinity of, there's going to be a negative that pops out, 1 over 5x to the 5th. Yep. And we're taking that from m to a. I want that to be less than or equal to 1 over 5,000. And let's go ahead and solve that. Negative 1 over 5a to the 5th minus a negative 1 over 5m to the 5th is less than or equal to 1 over 5,000. And now we can take the limit. Goes to 0. So we have 1 over 5m to the 5th is less than or equal to 1 over 5,000, which means that m to the 5th is greater than or equal to 1,000, which means that m is greater than or equal to 3.981. If you did that, and since the question is asking us for a value of m, it's always nice to round up. Always be conservative. It's okay to have error that's less than the requested error, but it's never okay to have error that's greater than the allowed error. So m equals 4 should do. And I went ahead and plugged that back in up here, and that gave us a value of 0.001952, which is indeed less than 0.0002. 0.002 is 1 over 5,000. So that's how you bound the tail.